Okay, guys, so this is lesson 6.6, reasoning about special quadrilaterals. I'm home tonight, and so I may have to stop periodically for life with the family, and I'm not feeling well myself now, and so I don't know how this is going to go, but let's try it. So, this is the last chapter, or last section in chapter 6, and we talked about all along how, we started with polygons, went to quadrilaterals, and then we divided quadrilaterals up into two specific types, parallelograms and trapezoids. And parallelograms and trapezoids are similar in that they both have one set of parallel sides, but a trapezoid has exactly one set of parallel lines. A parallelogram has two sets. And then a specific type of trapezoid is the isosceles trapezoid, and then the parallelogram is divided up into both a rectangle and a rhombus, and then from those two combined, we get the square. So, this is basically just identifying, using the properties that we've learned, the different types of quadrilaterals. And so this example, it says to determine whether the quadrilateral is a trapezoid, a parallelogram, a rectangle, a rhombus, or a square. And I see in the diagram that these diagonals bisect each other. AE is congruent to EC, and BE is congruent to ED. So I know right after that it is a special type of parallelogram. I can eliminate a couple of these. I can eliminate, let me get some ink here. I can eliminate a rectangle. Oh, my goodness. Okay, sorry about that. Eliminate a rectangle because it does not say anything about four right angles. I can eliminate a rhombus, although, well, actually AB and DC appear to be longer than AD and BC, so it doesn't even look like a rhombus. But where's my cursor? We cannot call it a rhombus even if it appeared to be, because it doesn't say anything about the length of the sides. And then we know it's not a square, because if it's not a rectangle, it's not a rhombus. It's definitely not a square. And so our choices are trapezoid and parallelogram. Well, we know from a previous lesson that diagonals bisect each other in a parallelogram, so we can eliminate a trapezoid because a trapezoid is not a parallelogram. So there's our first example. I think you'll find this lesson is rather simple, I hope at least. So here we have a few more examples. Example 2 says, are you given enough information in the diagram to conclude that ABCD is a square? Well, I see that all four sides are congruent, but I don't see anything about the measure of the angles. So we don't know that it's a right angle. The A, B, C, and D are right angles. So we're going to say no. Oops. Like I said, this is on Paint on my laptop in my living room. So not the best environment for a video, but it's what we have. That says no, by the way. And if we're going to explain our reasoning, we would just say squares have four right angles and the angles are not right. Alright, so in example 3, they ask us to identify a trapezoid. And the instructions say, are you given enough information in the diagram to conclude that EFGH is an isosceles trapezoid? Well, if we look at the relationship between, oops, what just happened? Sorry. Alright, if we look at the relationship between, there's not really anything good. Okay, so EF, line EF, or segment EF, and then FG and EH, we see that it's two lines and they are, one line crosses them. So it's two lines cut by a transversal. And so if you'll remember back, one of the things we learned to determine whether lines are parallel is if the same side interior angles are supplementary, then the lines are parallel. And that's what we see here. 120 plus 60 is 180, making FG parallel to EH. That's ugly, I'm sorry. So we know that it is a trapezoid. And then we see that F is congruent to G, E is congruent to H, and so we can say that it is an isosceles trapezoid because it's a trapezoid because it has the two parallel lines, and then a isosceles trapezoid because base angles are congruent. So we have some some checkpoint problems. I'm going to let Miss Cargill pause the video and give you a moment to complete these 3 problems. Alright, so looking at number 1, I see that while it's true, well, let me read the instructions first. It says, are you given enough information to conclude that the figure is the given type of special quadrilateral? And I see that while the figure has 4 right angles, it doesn't say anything about the measurement of the sides. So although it looks like it might be a square, we have to say no, because the sides aren't congruent according to what they've given us. Make that a little larger. So that would be a no. On number 2, we see that X and Z are congruent, opposite angles are congruent, Y and W are congruent, so those opposite angles are congruent. So we know this is a parallelogram, but it doesn't tell us anything about the side measurements, and so we cannot call it a rhombus. So this again is no. And then on number 3, I see right here that angle L and angle M are both 90 degrees. 90 plus 90 is 180. And so that means that these 2 same side interior angles are congruent, making line segment KL congruent to line segment JM. And so that is what a trapezoid is. It's a quadrilateral with 2 parallel sides. So this is yes. This is a trapezoid. All right, so one more page, 339, and there's just little checklist. And so they want us to put in a check mark if the shape always has the given property. So I'll find some ink. Let's use orange for Orange Out Day. And so both pairs of opposite sides are parallel. I know that is true for a parallelogram. A rectangle is a specific type of parallelogram, so it's also true for a rectangle. It's true for a rhombus. It's true for a square. I know you already know this, but a rhombus, a rectangle, and a square are all parallelograms. So anything that's going to be checked for parallelogram will likely be checked for those 3. Trapezoid is not a parallelogram. It does not have that property. Number 2, exactly 1 pair of opposite sides are parallel. That is our trapezoid. Everything else has 2 sets of parallel sides. Trapezoid has 1. Diagonals are perpendicular. That is true for our rhombus, and then our more specific rhombus, our square. And then diagonals are congruent, not in a parallelogram, but they are congruent in a rectangle, and they are congruent in a square. And so I hope that gets you started. The first few problems in your homework assignment is something very similar, just some different properties for you to think about. But your homework assignment is on page 339 to 341, and you're to do 5 through 23 and then 26. Like I said yesterday, best behavior, be nice. I'm not sure at this point when I'll be back, but hopefully, I'm hoping it's tomorrow. I really wanted to try to stay on track with having our test on Friday. And so that's why we are doing these video lessons instead of just a worksheet that will eat up your time. And so I hope you have a great day, and I will see you sometime soon. Thanks.